I think it's time to take one of these Riddex devices to bits, these pest repelling aids. This one came from eBay. It's probably not quite as authentic as the real thing. I'm not sure what's in the real thing. And this one came from Dilhanwy 2009, cost £1.88 plus 89p shipping. The bastards. Imagine charging me shipping charges, that's annoying. Especially when you're used to getting everything from China with free shipping. But the idea is, certainly going by Riddex's own adverts on the internet, you can see them. It's just blatant scaremongering. It shows like babies with cockroaches stuck to their foreheads and a woman sleeping in her bed, all happy, sleepy, bye-bye, lovely dreams, except someone's stuck a cockroach in her pillow and it's obviously going to eat her. So very much scaremongering. And the idea is that, according to their adverts, you plug this into the socket, turn it on, and magically it goes bing, bing, and all these like digital pulses. They actually call them digital pulses. All these spikes and digital pulses get fired along the mains wiring, and it makes all the insects and rats and things want to leave the house. I'm not sure whether that's actually a genuine effect, particularly given in this day and age you'd think that there'd be no insects in the houses at all with switch mode power supplies because they produce lots of spikes. In fact, to the best of my knowledge, the only things that don't like spikes in the power supply are metal oxide varistors and radio hams. But anyway, let's plug this in and see what happens. So here's a socket, here's a death adapter. Now this death adapter is rather stylish. It's the black version with the purple band, and although it's got the screws from the metal contacts inside onto the pins, it does unfortunately have a sleeved earth pin. Now where have I got a socket near here? There's a socket, a double gang socket. Now the thing about British plugs and the sockets is that the first connection that makes contact is the earth pin. That's it making connection now. And the idea is that, you know, no matter what happens, whatever you plug in is grounded. And then that goes in, it unlocks the shutters, if it's the correct plug size. It goes in and makes connection fully. And that, because the metal contacts to the earth are right up close to the end, I reckon that might actually be defeating that. So I'm going to give that a blast. Let's put this to continuity. And we'll see what happens. So let's go into the earth connection in the back here and go in here. It's completely defeating the earth connection. Yep, the earth pin is fully in, but there's no earthing. So that makes that a particularly stylish and exciting death adapter. Worth noting. If you ever get an appliance from China, make sure, if it's a square pin plug, make sure it's not got this sleeving. The live and neutral should be sleeved, the earth should not be sleeved. If it is sleeved, it defeats the earth, unfortunately. So let's defeat the earth. This is 2-pole, it's not really, it's not got an earth connection. And we'll plug this in. And what initially happens is the green power light, well, it's going to look very strobe because, well, it's sort of doing an iPad thing. It does suggest the power supply is quite choppy. It's got a red flashing LED, and if you press this button, this blue LED lights and starts visibly flickering the iPad as well. They're not really visibly flickering much, but the iPad's making them look all flickery, as it does. So yes, 3 LEDs, a green one, a red one, and a blue one. They've covered all areas regarding the colours. I'm not going to try and measure the power because I know from previously plugging it into the power meter it's not very high. So I'm going to open this now. It's not got screws, I'm hoping it's not glued shut. It feels flexible at the sides. This is a good time to mention that I'm going to be doing a question answer thing. I was inspired by Cody's lab, he did that. So if you guys have any questions that you want me to answer, anything goes really. This is just pressed together, look at it. Leave them in the comments below. And I'll answer selected questions in a future video while carefully avoiding all the really awkward questions. So yes, questions and answers. I was expecting more in this than that. I'm seeing resistors, I'm seeing diodes, I'm seeing LEDs and a capacitor. Is there anything in the back of the circuit board? No, there's not. It's fake. I don't know if the real thing's fake or not, but this is certainly fake. So let's doodle this. Let's work this out. So we've got this connection coming from the mains going to all the resistors, through the LED, back through a diode. All the diodes are connected to this terminal. Right, notepad. Not that it's going to take a lot to draw this out. Notepad, where's my pen? There's a pen. So let's just adjust the contrast down a bit and draw this marvellous device. I do quite like the case. The case has potential. It's actually worth it for the case. So many of these products are. So the diodes are all pointing, so let's go. This is 240 volts. It's actually designed for 220 volts. It's designed for the Chinese market. We've got one connection going to the diodes. The diodes are all pointing down the way. So let's start with the one with the switch. The one with the switch is going up to that LED up there. Diode, LED, switch, and the other resistor. So diode, LED, that's the blue LED, the switch, and then a resistor, 100k resistor. They're all 100k resistors, quite beefy resistors. They look kind of half watt, 1 watt type things. They look metal film as well, so they're probably 1 watt resistors. So what about the next one? Let's go with flashing LED next, the one that flashes on and off. That's got diode, LED, flashing LED. I'll put an F next to it. That's going straight to the resistor. And it's also got a capacitor across it, which will be in this polarity. And that's probably so it wouldn't flash if it was just fed with half-wave rectified the supply. It would just keep resetting. The capacitor value is 100 microfarad, 10 volt. And that just leaves the last LED, which is the green one. And it's the simplest. It's basically going through the LED to the resistor. And that's it. So let's do the maths for this. This is very similar to that little LED, the charging circuit in this little LED flashlight I did in a previous video. Let's do the maths here. So 240 volts. Because it's 240 volts divided by 100k equals 2.4 milliamps. So that's 2.4 milliamps, but it's not going to be 2.4 milliamps because there's a diode. It's only going to be on for half the time, which means that the current through LEDs is going to actually be 1.2 milliamps. So basically just say a milliamp. Not much. And the power dissipation in the resistors, current times 240, so that's roughly 0.6 watt, but it's divided by 2, so they're going to be dissipating 0.3 watts. They're going to stay cool. And the whole thing, when it's on with all the LEDs, is going to draw approximately 1 watt tops. But having said that, it's not going to do much. So that's interesting. They could have actually done this differently. They could have reduced the number of components. Let's redesign it for them. So here's the mains come in 240, let's say 220s, because it's nice for the Chinese, because that's what their voltage is. They could have used one diode. Oh, you know what? The flashing LED would make the others modulate. It might need its own circuit, but they could have put 2 LEDs in series with 1 resistor. The same value, 100k. And then they could have put the switch across one of them so that it went out when the switcher is closed. So that would remove 1 diode and 1 resistor. The flashing LED, technically speaking, they could have actually just slipped another LED in with the capacitor across it. But it might have modulated the LEDs, the other LEDs on and off, so it might have been better with its own resistor. So that diode could possibly just be used to feed them all and go through that circuit with the capacitor across the LED and our resistor again. So that would have cut it down from 3 diodes to 1, so I've saved them 2 diodes and 1 resistor. Bargain. All these things count when you're selling cheap shite. Right, so yes, intriguing. It makes me wonder what's in the real thing. Are these just quackery? But this one certainly is. This is completely fake. But there you go, all the better for it. I quite like stuff like this slight quackish stuff. It's quite pleasing. As I say, it is a nice case. That has potential for other applications. It's got loads of circuit board mounting positions inside as well. And of course the holes for the LEDs. So you could do quite a lot with that. Or just relabel it Super Whole House Power Saver. Yeah, interesting device. So, as I said earlier, if you've got any questions for me, just ask them down below in the comments section and I'll do a questions and answers style video. So, yes, good result from the case, bad result from the contents.